This is the topic of A2 differentiation for A levels. The question is there. The diagram shows the graph of curve y equal to 1 minus x over 1 plus x square root. Part 1. By differentiating 1 minus x over 1 plus x, obtain an expression for dy by dx in terms of x. Hence, show that the gradient of the normal to the curve at the point xy is 1 plus x multiplied by 1 minus x square and then square root. Part 2. The gradient of the normal to this curve has a maximum value at the point P shown in the diagram. Find by differentiating the x coordinate of the point P there. अब इसमें हमारे पास जो कर्व गिवन है दैट इज इक्वल टू 1 माइनस एक्स ओवर 1 प्लस एक्स, जिसका सबसे पहले हमने dy बाई dx निकालना है और फिर इसका नॉर्मल निकालना है. So this can be written as 1 minus x over 1 plus x whole power half. Now we will use the product rule of u over v, which is basically equal to, if y is equal to u over v, then y dash is equal to v square, v as it is u derivative minus u as it is into v derivative. So this formula will be used in this problem. Y equal to 1 minus x over 1 plus x power half. So dy by dx, first power will be used half into 1 minus x over 1 plus x power minus half. Now power is not there, and rest of the thing is 1 minus x over 1 plus x, for which we will use the quotient rule v square 1 plus x whole square. Now 1 plus x as this into the derivative of 1 minus x, which is minus 1, minus 1 minus x as this into the derivative of this x is 1, and this thing will become equal to half 1 minus x 1 plus x power minus half 1 minus 1 minus x minus 1 plus x over 1 plus x whole square. This minus x and plus x is going to be cancelled out. That thing is equal to half into minus 2 into 1 minus x over 1 plus x whole power half into 1 over 1 plus x over 2. So this 2 and 2 cancel out, so it should be left there minus 1. 1 minus 1 plus x power half over 1 minus x power half into 1 over 1 plus x power 2, which you can write it as minus 1 into 1 divided by 1 minus x power half into 1 plus x. Here power is 2, here power is half, so it will be shifted to the denominator. So this value will become 3 by 2. This thing is equal to dy by dx, and that thing is equal to minus 1 over 1 minus x power half 1 plus x power half into 1 plus x. This thing is equal to minus 1 over 1 plus x into 1 minus x squared, because the power is same. So a plus b or a minus b will become 1 minus x squared and 4 power half. This is the value of n. Since we are talking about the gradient of the normal, so when it is the normal to this curve, then we know that slope will be minus dy by dx. So this minus and minus will become positive, and it is in the denominator. So the slope of normal to this curve is 1 plus x into 1 minus x squared root. And that thing we are going to show that the normal to this curve is 1 plus x into 1 minus x squared root of that equation. Now in the second part, the gradient of the normal to this curve at the point P is maximum. Since we have this is the slope of the normal, which is equal to 1 plus x, 1 minus x squared. So again we will differentiate it dm by dx, that is equal to d by dx of 1 plus x, 1 minus x squared root. Here it is a product of the two functions. So when it is a product of two functions, then we know that dy by dx is equal to v as it is u derivative, u as it is v derivative. So this equation will become 1 minus x squared root into x derivative is 1 plus 1 plus x as is into half 1 minus x squared power minus half into minus 2x. This is the differentiation of this part here. This 2 and this 2 cancel out. So it is left equal to 1 minus x squared root minus x into 1 plus x over 1 minus x squared root. If we take the LCM here, 1 minus x squared root, it should be 1 minus x squared minus x into 1 plus x squared. Because it shows the maximum value of that occurs at the P point. So 1 minus x squared minus x squared over 1 minus x squared root should be equal to 0, because it is the maximum value of that. So that thing is equal to 1 minus 2x squared minus x should be equal to 0. Or 2x squared plus x minus 1 is equal to 0. This thing will become 2x squared plus 2x minus x minus 1 equal to 0. Here 2x is common, x plus 1 minus 1 is common, x plus 1 equal to 0. Or x plus 1 into 2x minus 1 equal to 0. So either x equal to minus 1 or x equal to half. But p lies on the right side of the origin, and so x value is equal to half is the x coordinate of this point p here.